The climate system is constantly trying to balance the Earth's incoming energy with outgoing energy. So as heat reaches the Earth's surface emits heat back out to space in the form of infrared light. Some of the heat is released, but some is trapped by greenhouse gases in the atmosphere to help our planet stay warmer than it would otherwise be without them. Greenhouse gases allow the solar radiation to come in, but block the infrared light emitted by the Earth's surface from leaving the lower atmosphere, which is where we live and where weather happens. Some greenhouse gases naturally cycle through Earth's systems, moving from the air to living things, to water or snow, and ice or land as they are absorbed and stored away until they are eventually released again. When this natural exchange moves in a steady pace, the greenhouse gases are regulated and the global temperature is stable. But if a high concentration of greenhouse gases is released too quickly, it throws the climate system out of balance. Carbon dioxide, also known as CO2, is one of the most abundant greenhouse gases in today's atmosphere. It can be naturally emitted by volcano eruptions, fires, and living things through respiration, or it can also be released from human activities, mostly from deforestation and fossil fuels. Once CO2 enters the atmosphere, it influences the Earth's temperature and overall climate system during the thousands of years before this carbon cycles back into the rock reservoir. But although CO2 is the most abundant greenhouse gas, there are other greenhouse gases that are even more potent, like methane, which can be naturally released from wetlands and melted permafrost as bacteria decomposes dead plants and animals. Or it can be emitted by human activities, mostly from livestock raising, rice agriculture, and fossil fuel burning. Methane concentrations are lower than carbon dioxide, but methane is 25 times more potent and lasts about 12 years in the atmosphere. Nitrous oxide can also be emitted naturally through the nitrogen cycle, which circulates nitrogen between the atmosphere, plants, animals, and microorganisms that live in soil and water, or through human activities related to agriculture, fossil fuel burning, wastewater treatments, and chemical production to create synthetic products like nylon. When compared to carbon dioxide, nitrous oxide is 298 times stronger and lasts about 114 years in the atmosphere. The only greenhouse gases that do not have natural sources and are 100% human-made are fluorinated gases. These gases have a very high warming effect relative to other greenhouse gases. They can be tens of thousands times stronger than carbon dioxide and will linger in the atmosphere for hundreds to thousands of years. So even small emission amounts can have a disproportionately large impact on the climate system. The most potent is sulfur hexafluoride, which is used to transmit electricity through the power grid. Another one is called perfluorocarbons and is emitted through industrial processes such as aluminum and semiconductor manufacturing. And hydrofluorocarbons primarily come from refrigerants that are used for air conditioning systems in vehicles and buildings. Or they can be used as aerosol propellants, foam blowing agents, solvents, and fire retardants. These hydrofluorocarbon chemicals were created as a replacement for stronger chemicals that were banned because they were depleting the ozone layer. In the upper atmosphere, ozone helps protect us from UV rays that can cause skin and other cancers. But in the lower atmosphere, ozone molecules also act as a powerful greenhouse gas with a high capacity to absorb heat, making local temperatures hotter and even increasing the likelihood of heat waves. Lastly, water vapor is the most abundant and powerful greenhouse gas with a concentration that continues to increase with global warming because of the water vapor feedback cycle. More greenhouse gases creates warmer air. Warmer air expands, and it is therefore able to hold more water vapor. And since water vapor absorbs heat, more water vapor results in warmer air. At which point the cycle starts over again, with warmer air that leads to more water vapor, which absorbs more heat, and so forth, ultimately making our planet warmer. Along with these main greenhouse gases, carbon dioxide, methane, nitrous dioxide, fluorinated gases, ozone, and water vapor, there's also aerosol particles floating in the atmosphere that can either cause a warming or cooling effect. In the next video, we'll talk about where aerosols come from and how they influence the climate.